Welcome to this overview of how Bell Equipment is leveraging technology to make our trucks leaders in safety, easy operation, performance and value. Over the next few minutes you'll complete a typical work cycle and experience some of the innovations that set Bell apart. Bell designers have focused on making our trucks easy enough for just about anyone to operate. After adjusting your seat and fastening the seat belt, you'll notice how simple and car-like the cab is laid out. A steering wheel, an accelerator and brake pedal, a simple dashboard with a central information display, and most all other controls grouped on an easy-to-use switch unit. Beginning with the MK6 generation, Bell trucks now feature a keyless start system. A 4-digit authorization code is required to activate the truck. Where multiple drivers may operate the same truck, each driver can be allocated a unique code. The truck's onboard event recorder will then log events and report activity for each operator. Once the code is entered, starting is automated by the onboard computer. A simple push of the start button will first sound the horn as a safety alert, then crank the engine till it starts. Should the engine fail to start, the computer will protect the starter motor and batteries by limiting cranking time and enforcing a cool-down period between cranks. This is a typical example of Bell Equipment's philosophy of building in protection. Drive or reverse is selected on the switch unit. Before enabling the transmission, the computer will again sound the horn, once for forward and twice before enabling reverse. This acts as an additional safety measure that supplements the backup alarm. Before we start a work cycle, let's demonstrate how Bell engineers have advanced safety by automating the park brake function. There have been cases of trucks rolling over a disembarking operator because he forgot to apply the park brake. Now on a Bell truck, the park brake is applied automatically whenever neutral is selected or the engine is shut down. Driving off with the park brake applied is also a risk, so the computer controls this situation as well by releasing the park brake when a gear is engaged. To prevent rollback on a hill, the computer uses input from an inclinometer that measures the slope and then only releases the park brake once the throttle has called for sufficient engine torque to overcome the grade. Even on an abnormally steep slope, a Bell truck can pull away safely without any dangerous rollback, thanks to a little innovative intervention from the engineering team. Now, as we begin the loading part of the cycle, we'll experience another Bell exclusive. All Bell trucks are factory fitted with a fully integrated onboard load weighing system. This consists of sensors in the suspension system that interpret the load and show this on the display unit. This information is also used to optimize the transmission shift patterns and adjust the suspension settings. Once the loading is complete, the payload value can be transmitted by satellite telemetry to Bell Equipment's fleet monitoring system known as FleetMatic. Customers can subscribe to FleetMatic and receive detailed information on every aspect of their truck's operation, such as load size, cycle time, fuel consumption, or idle time, along with any abnormal or dangerous events, such as overtemps, and overload, or overspeed situations. With FleetMatic, customers can remotely monitor their trucks and identify opportunities to fine-tune the fleet. On the loaded haul part of the cycle, there are a number of factors that help Bell trucks outperform the competition. Fuel-efficient, built-for-trucking engines are coupled with efficient transmissions that feature minimal frictional losses and fewer rotating parts. These are integrated in a weight-optimized total truck design that eliminates carrying any dead weight, the key to moving more load with the least fuel. Another important feature of Bell trucks is the large capacity non-wearing braking capability known as the retarder system. The Bell retarder actuates automatically whenever the operator removes his foot from the accelerator. The retarder consists of the engine brake, which uses compression to produce braking energy, and a transmission retarder that creates resistance through an oil shear effect. An effective retarding capacity allows a truck to descend grades in a safe way while boosting cycle times. Believe it or not, production incentivized operators have been known to select neutral for even more speed on steep downhills. This is an extremely dangerous practice, as it overrides the retarder system and risks catastrophic damage to the drivetrain. Today on the MK6, software now restricts the selection of neutral above a virtual crawl speed. Another important safety feature of the MK6 generation is a speed limiter function. It is common practice on most mining sites today to have speed limits in place. The speed limiter function is actuated from the switch unit. Once actuated, this caps the truck's speed to the limit selected, regardless of the throttle position. On a downhill, the computer will intervene and apply the retarder as required so as not to exceed the speed limit, even if the operator continues to apply full throttle. As we maneuver into position to tip the load, you could be looking for the traditional dump lever. Well, it's been left off the new generation Bell trucks. Whereas previously an operator had to apply the park brake, place the transmission in neutral, raise the engine speed and pull on the tip lever, these actions have now been automated and combined into a simple tip function switch we call iTip. All the operator need do is position the truck and push the tip switch on the thumb pad. Automating all the other steps eliminates the chance of dumping a load without the park brake applied. To further boost safety, Bell engineers have added an additional safety override. The ground at tip sites can sometimes be unstable. Should it give way under one side of the truck, an unstable condition results. Now, using the information from the rear chassis inclinometer, if the computer senses an excess lateral angle, it will intervene and prevent the tip. At the same time, it will display this message on the screen, requiring the operator to reposition the truck. So while dumping the load only occurs once a cycle, in some applications the truck may cycle up to 20 times an hour. So the iTip innovation is a major advance in reducing operator workload. At the end of the shift or whenever the engine is shut down, it's good practice to allow a cool down period for temperatures to stabilize in order to protect highly stressed components like the turbocharger. Today on a Bell truck, the computer will automatically enforce an idle period before shutting down the engine. It even adjusts the length of the cool down run according to how hard the engine was working prior to the stop button being pushed. So there you have it, a quick overview of how Bell is leading the way in building smarter trucks that simplify life for owners and operators. It's a close relationship Bell designers and engineers enjoy with our customers that helps us ensure each new generation of Bell trucks better meets their needs, improving safety, productivity, and delivering the lowest cost per ton of material moved.